Hey everyone, welcome to our YouTube channel, and in this video we are going to discuss a very important topic of the applied electronics, that is the average and the RMS value of the alternating current. Now in our last video we basically discussed in detail about what exactly is the root mean square value of the alternating current here. So we first discussed the graph, and based on that we had studied this small derivation in which we kind of derived the value of the IRMS. So this video is basically in continuation to the last video, and I hope that you like, share and subscribe to our YouTube channel. So first of all, if you notice this graph here, there is this sinusoidal waveform that represents the alternating current. The highest value of this peak over here is represented by Im. Now there are two values associated with this graph. The first one is 0.707 Im, which is called the RMS value, and the second one is 0.637 Im, which is called the average value. So as far as the definition of the average value of the alternating current is concerned, so the average value, also called the DC value of an alternating current, is expressed by that steady or DC current which transfers across any circuit the same charge as transferred by that of an alternating current during the same time. So now what happens is that in case of a symmetrical alternating current waveform, that is like this one, a current whose positive and negative half cycles are equal, see the average value over a complete cycle is 0. So hence in that case the average value is obtained by adding or integrating the instantaneous value of the current over 1/2 cycle only. So when we talk about 1/2 cycle, so now that would mean that the value of IDC would be equal to 1 divided by pi integration 0 to pi, and then we have I d theta like this. So this would be equal to 1 divided by pi integration of 0 to pi, and then we have I max sine theta d theta, and this is because the value of I is represented by I max sine theta. So we have substituted this value of I in this expression over here. So now if you notice, we can take out the constant parts outside this. So the value of IDC would now be equal to I max divided by pi, and integration 0 to pi, then we have sine theta multiplied by d theta. So integration of sine theta is minus of cos theta, so this would be I max divided by pi, then we have minus of cos theta, and the limit goes from 0 to pi over here. Now let us solve this. So when you solve this, you get the value of IDC as equal to I max divided by pi, and then we first substitute this the upper limit and the lower limit of the integration. So this is minus cos pi is minus of minus 1, so this would be minus 1 minus, and then we have cos 0, which is 1, so this would be minus 1 over here. Now when you solve this, the value that you get is 2 times Im divided by pi. Now 2 divided by pi is roughly around 0.637, and that means it comes out to be 637 of I max. So technically in this derivation we have basically derived that the average value or the DC value of the current is 0.637 I max. So I hope that this video was informative enough, and for more such videos don't forget to subscribe to our YouTube channel. Thank you so much for watching. We will meet soon, and goodbye.